Okay, let's dive right into this, because today we're tackling a question that is, well, it's one of the biggest in all of physics. And we're going to explore a really radical new idea that tries to answer it by asking, what if our reality is running on some kind of cosmic source code?
So it all starts with a huge problem. I mean, a universe-sized problem. For decades now, we've been looking out into space and realizing most of it is missing. But the big question here is, what if it's not missing at all? What if we've just been, reading the instruction manual for reality completely wrong? And this, right here, really shows you the scale of what we're talking about. Look at this. Everything we can see, every star, every galaxy, you, me, this planet, all of it makes up that tiny little 5% slice. The other 95%? Well, that's made of two things we know next to nothing about. Dark matter, which kind of holds galaxies together, and dark energy, this bizarre force that's pushing the entire universe apart.
Now, the standard way of thinking is that these are two totally different, weird things that we just haven't been able to find yet. But this new hypothesis, it suggests something way, way more elegant. It says, what if dark matter and dark energy aren't separate things at all? What if they're just two different effects of one single, deeper reality, an underlying cosmic code?
To even get our heads around this, we have to start by completely rethinking the most familiar force there is. We have to look at gravity not as this fundamental thing, but as, well, maybe a glitch in the system. And this is the absolute key to the whole idea. The theory proposes that gravity is what's called an emergent property. Think about it like this. Your consciousness isn't in one single brain cell, right? It emerges from the mind-bogglingly complex interactions of billions of them. So what if gravity isn't a basic ingredient of the universe, but something that just emerges from the behavior of a much deeper informational layer?
An emergent property is basically where the whole is so much more than the sum of its parts. A perfect example is the wetness of water. A single H2O molecule isn't wet. Not at all. Wetness only happens, it only emerges when you get billions and billions of them all interacting together. So this theory is asking a wild question. Could gravity just be the wetness of space-time?
And if you accept that, then suddenly our two biggest cosmic mysteries might just click together. In this picture, dark matter and dark energy stop being two totally separate headaches. Instead, they become like water and ice. They're just two different phases of the same underlying thing, this cosmic code. One state of the code clumps up and acts like dark matter, and another state pushes apart and acts like dark energy. So, okay, how does this actually work? If reality is like software, then we gotta understand the hardware it's running on. And this theory gives that hardware a name, the metapole. I mean, that's the logical next question, right? If there's a code, there has to be something that holds the code, a medium. What is this stuff that's holding all the information about how the universe is supposed to work? Right at the very heart of this theory is this idea of the metapole. And honestly, the best way to think about it is as the universe's hard drive. It's this fundamental field that's everywhere, in all of space, and its job is to store all the information that tells space-time how to bend and matter how to move. And here it is. This is the core of the theory, written in the language of physics. Now don't worry, this isn't a math test. We're just going to read this like a sentence. On the left, you've got the shape of space-time. On the right, you have all the stuff, matter and energy, that tells space-time how to curve. And that new bit, that T meta, that's the secret ingredient. That's the metapole, the cosmic hard drive, making its presence known. Now let's zoom in on that new piece, because the theory says the metapole itself isn't just one simple thing. It's actually made of two different parts, represented here by K and M, and these two parts are locked in a constant cosmic tug-of-war. And this is where it gets really, really interesting. This is how that cosmic conflict is defined. You've got the K tensor, which is the code itself. It's the pure, perfect blueprint for reality. It's the force that builds things. But then you've got the M tensor. That's the memory, or the friction. It's all the universe's history, its inertia. You can think of it as a kind of informational drag that fights against change. So you have this creative force and this resistive force literally baked into the fabric of reality itself. All right, now if you thought that was wild, you need to buckle up, because this is where the theory takes a turn into some seriously profound territory, connecting the rules of information to the laws of heat and energy, and giving us a totally new origin story for our universe. Okay, so we've all heard of entropy, right? Thermodynamic entropy. It's the idea that things tend to get more disordered and messy over time. A clean room gets messy, not the other way around. But this theory introduces a second, opposing type of entropy, structural entropy. This measures the messiness of the cosmic code itself. And here's the kicker. Unlike regular entropy, this structural entropy can decrease. The code can actually get cleaner and more ordered over time. And this leads to a conclusion that is just stunning. See, there's this rule in computing called Landauer's principle, which says that erasing information always costs energy. It always generates heat. This theory just takes that idea and applies it to the whole cosmos. It suggests the Big Bang wasn't a creation out of nothing. It was the massive burst of heat and energy generated from wiping the universe's hard drive, the metapole, clean, getting it all fresh and ready for the next cosmic cycle. But, and this is crucial, there's no free lunch in the universe. For the cosmic code to get cleaner and more ordered, a price has to be paid. And that price is a massive amount of heat and disorder, regular entropy, in the universe of matter and energy. This generalized second law just makes sure the cosmic books are always balanced.
Now, I know what you might be thinking. This all sounds like some pretty wild, mind-bending philosophy. But what makes this science is that you can actually test it. The people behind this are very clear. This is not just a cool story. It's a framework built to make real, concrete predictions that could be proven wrong.
And that right there is the most important part. For any new idea in physics to even get a seat at the table, it has to offer a way to be falsified. And this theory does exactly that. It lays out a series of very clear pass-fail tests against what we can actually see and measure in the universe. And this shows you exactly how it's done. It's the scientific method in action. You start with Einstein's general relativity, which we know works incredibly well. Then, you carefully add the new piece, the metapole. And then comes the big test. You check if this new, modified theory still matches what we see in the real world. If it breaks something we already know is true, then it's game over.
And here are some of those make-or-break tests. The theory absolutely cannot mess with the super precise measurements of gravity right here in our own solar system. It has to predict that gravitational waves travel at the speed of light, something we've actually observed. And, of course, it has to line up with everything else we see on the grandest cosmic scales. These are tough, tough hurdles that any challenger has to clear.
So while this is definitely still a bold new idea, it's a fascinating one because it offers a single unified solution to some of the biggest puzzles in cosmology. And it leaves us with this final, really provocative question to chew on. If our universe is running on a kind of software that has both a creative drive and a resistive memory, does that mean the laws of physics themselves aren't set in stone, but are actually evolving over cosmic time?